So looking at our schedule here, we're on class 12. We're into packet 2. Just so you know, the structure of every test unit is the same. So we have a packet. This packet covers all the material up through test 2. And at the end of the packet is a study guide for test 2, just like there was in packet 1. And we will have one quiz and one project being due before the next test. So it's like sort of the same structure as before. All right, so looking at the one quick preview exercise here. Find f of 0. So this is a graph of a function, y equals f of x. We just learned the word function and this notation, f parentheses x last class. So this is just a little practice, f of 0. That means when 0 is in parentheses, is it an x or a y? It's an x. Good. So they're giving me the x and they're asking me for the y. So what is f of 0? 3. Great. All right, and now they're asking me to find x values when f of x is 0. And f of x is just a fancy way of writing, a new fancy way of writing what we used to call y. So they're giving me a y coordinate of 0 and asking for the x coordinates. What x coordinates will give you a y coordinate of 0? -3 and 2. There are 2 points on the graph that have y coordinates of 0. X equals -3 and x equals 2. All right, so a new vocabulary word, which I will introduce again, but just so you know, -3 and 2, those are called the zeros of the function f, because those are the x values that make the function equal 0. The real when zeros are real numbers, then we call them the x-intercepts of the graph. Okay, so we talked about domain and range before, right? The domain is the set of all inputs, first coordinates. The range is the set of all outputs or second coordinates of a point, of a set of points. So identifying the domain and range from a graph just means figure out all the x coordinates that the graph lives on and all the y coordinates that the graph lives on. So if this is a graph y equals f of x, its domain is the set of x coordinates that it lives above, right? And its range is the set of y coordinates that it lives on. So let's do an example where we find domain and range. Okay. So to find domain, you look along the x-axis to find inputs that correspond to points on the graph. So I was going to use interval notation here. I would be looking at this graph. I'm only looking along the x-axis. And I would say, okay, what's the smallest x coordinate that lives on this graph? -7. Great. So my domain starts at -7. Should I include that -7? Yes, because there's a closed circle on -7. So we know that point is included on the graph. So I include it. And then I put comma. And I'd say, okay, what's the largest x coordinate on this graph? Infinity, because that arrow moves to the right forever. So to find the range, we look along the y-axis and look for y coordinates or outputs that correspond to points on the graph. So what's the smallest y coordinate on this graph? -2. Good. And I'm going to include it because there's a closed circle there. And then what's the largest y coordinate on this graph? Infinity, because that arrow indicates it goes up forever. Okay, even and odd functions. An even function is just a special way of saying that a function that has symmetry about the y-axis. So if you look at its graph, that means that if you fold it over the y-axis, the two halves look the same, right? Algebraically, that means that if you plug in opposite x values, right? You plug in a -x and a +x, that you'll get the same y. Okay, so if you plug in opposite x values, so if you go to the right a certain amount and you go to the left the same amount, you get the same y coordinate. Okay, that's how we algebraically describe what we visually see as symmetry. So for example, if I plug in 2.5 and negative 2.5, in this picture, this x coordinate is 2.5, this x coordinate is negative 2.5. They both give the exact same y value of negative 14.44. Okay. Now an odd function, odd is just another way of saying that a function displays something called origin symmetry. So with origin symmetry, you have to make two folds, fold over the x-axis and then fold over the y-axis, and the two pieces of the graph will line up with each other. So we call that origin symmetry. And the algebraic notation that describes origin symmetry says that if you plug in opposite x values, plug in a negative x and you plug in a positive x, instead of getting the same y value, now you get opposite y values. Okay. So for example, in this picture, if I plug in 1.28 and negative 1.28, I get my y values are now opposites of each other. I get 12.13 and negative 12.13. Okay, so opposite x values give opposite y values. So to conclude, right, just a little summary, an even function has opposite x values have the same y value. In an odd function, opposite x values have opposite y values. Is that really the whole demo? That is. Okay, you get a short one today for a lecture. You can start the activities, and I'll be around to answer questions.